In this video, we're looking at BMAT 2020, Section 2, Question 13. So we're asked, how do these processes change the atmospheric gas composition? So we've got some different cellular processes here. We need to work out how they change the gas composition, namely oxygen and carbon dioxide. So let's start with combustion. How is this going to change the amount of carbon dioxide and oxygen in the atmosphere? Can we think of the equation of combustion? Well, generally, it's some fuel, whatever your fuel is, plus your oxygen, and it completely combusts to carbon dioxide and water. So now we can move on to aerobic respiration. Can we think of the equation for aerobic respiration? Well, we've got glucose plus oxygen is carbon dioxide and water. Now, an anaerobic respiration is a little different to the aerobic respiration, and we know it doesn't use oxygen, anaerobic. So what's the equation for this one? Well, it's glucose straight to lactic acid in animals. Our plant aerobic respiration is exactly the same as our animal one. Glucose plus oxygen goes to carbon dioxide and water. And our photosynthesis, well, we know that's going to be exactly the opposite. We're going to have our carbon dioxide and water to glucose and oxygen. And now what do decomposers do? How do decomposers change the atmospheric gas? Well, decomposers, they do respire as well. They take the organic matter from plants and animals with their oxygen and convert it to CO2. So now we've got our processes and our equations, we can start to fill out these headings. So we're looking for things to add and remove CO2 and adding and removing oxygen. So if we start with combustion, we're seeing we're taking away oxygen from the atmosphere, using it to combust our fuel, and we're releasing CO2. So we can move that into our adds CO2, and then we need another one to go into our removes oxygen. So take a second and see if you can work out how these other ones are going to fill up our little table here. So I've filled out our table here. With our animal aerobic respiration, that's this equation, we can see we're taking in oxygen and releasing carbon dioxide. So it's adding CO2, removing O2. And that's exactly the same for our plant aerobic respiration. Then we've got the opposite case in photosynthesis, that's removing CO2, adding O2. And then for our decomposition, our organic matter is taking in O2 for decomposition and releasing CO2. So that's the top and bottom categories there. The only one we can't fit in this table is the anaerobic respiration, because that doesn't use oxygen or release carbon dioxide and doesn't take in or release the others either. So that one is left on its own. So now we've got all of our answers filled into the table, we can go to our answer table and see which one of these fit in the correct answer, and our answer is going to be D.